And you're live.
Welcome, everyone. Welcome back. This is our second, not Fast and Curious, it is our second VIA Visionary series for 2024. We're excited to be here and have the opportunity to speak to you all. Our guest today is Arnab Chatterjee, who is joining us from the EMPA lab in Switzerland, happens to be in town today. And so we took the opportunity to invite him in, and so excited to have you here. Thank you very much for making the time to speak with us today.
Thank you for having me. It's a pleasure to meet you finally in person.
We have been talking on video. It's one of those things, the virtual world during, I want to say it's been a few years during COVID, et cetera. It's like, you can't meet anybody, but happy to have the opportunity to finally meet in person.
Pleasure to visit here. Thank you for having me.
Of course. Well, first, let's start out. You have, welcome to the United States. You have this tremendous multicultural background, national background. So we're starting in India and then Italy and Switzerland. Tell us a little bit about how'd you come to Europe, and tell us about your journey.
Sure. Yeah. I mean, it all started from my hometown in India. So when I was doing my bachelor's there, so that was in the Jadavpur University, based in Kolkata, India, and when I was almost towards the end, I was thinking, what next? And naturally, I was a bit academically inclined, let's say, and I was exploring. So, should I do a master's?
Yeah.
And I said, yeah, maybe I can do a master's.
Yeah.
And we have an extended alumni network, so based all over the world, in US, in Australia, in Europe. And I got in touch with few of them to, just to understand how they feel, or if they can just guide me on what I can do. And so that was kind of my first exploration. And also, I think I was fortunate enough to be supported by my family in this kind of ambition, let's say, to go abroad for studies. And on my personal side, I think I kind of knew that I want to work more in the domain of buildings, because in the civil engineering, when you start, you focus on buildings, roads, bridges, dams. But then for me, buildings was where my passion lied.
Yeah.
And I was looking for, let's say, courses where I could further my knowledge in buildings. So, and I found one, or let's say I found many in Europe, in USA, but the one in Milan, so in Politecnico di Milano, which was called the building engineering course, grabbed my attention because it was like a course that focused on the multiple assets of buildings, so energetic analysis, structural analysis, then also design of the different envelope elements, but also touching a bit on the user behavior side as well. And receiving a scholarship made the decision easier.
Yeah.
So then I was at Italy doing my master's. And then, of course, by the time I already knew that I wanted to do a PhD. And since my experience in Italy was great, I didn't want to go too much far away from Italy. And at the same time, I wanted to do a PhD from a place, where there are excellent research facilities, where they value innovation at the same time. Of course, in Italy, they do as well. But I mean, I think in Switzerland, it's on a different level altogether. And of course, receiving this admit from EPFL, which is consistently ranked like top 10 or top 20 in the world, I think that was a great push towards, let's say, having a great PhD there. And I think also the topic that I found there for my PhD was quite, let's say, stimulating for me, exploring how we can make buildings more energy efficient without ignoring the users. So also taking into consideration the thermal comfort aspect of the user. So yeah, that's kind of the journey to the PhD and here.
Oh, terrific. So we're going to come back to the user part, because I think it's often overlooked. And when people talk about engineering and buildings, we think about the materials, right? Okay, but we're going to come back to that in a second.
Sure.
It's a tremendous journey. I think being in the U.S., we sometimes are U.S. centric, especially in our neighborhood where we have Harvard and MIT, and we're like, oh, everybody just goes and does their, comes here. And of course, Milan's a nice city too. There's a beautiful, opportunity.
Yeah, also, MIT, doing a PhD or a master's in MIT would have been a great thing as well. But yeah, there are different ways So it's
and and 1,000-year history also of architecture and design and engineering, right? That goes back. So there's lots to there's
sure, absolutely. I mean, like among my shortlisted universities when I was looking for a master's or PhD, definitely there were some institutes from USA as well, but maybe in a parallel universe, I am in USA. So
That's right. That's right. It's in the multiverse. There is
in
an
the
Arnab that
multiverse, yeah,
we did
exactly.
his thesis. Well, terrific. Well, we're glad that we have the opportunity. After, I mean, EPFL, as you say, is considered, often ranked number one. You're being modest about top 10, often ranked number one in a lot of
Yes, true,
rankings
true,
around the world, especially in engineering and science
sure,
innovation. Could have gone a lot of places. You chose EMPA,
sure.
actually. Can you tell us a little bit about EMPA and the lab there and your work?
Sure. So EMPA is a research institution that is, let's say, focusing more on application-oriented approach, and we, for example, like it's in the ETH domain, and in the ETH domain there are some other institutes like EPFL. There is ETH Zurich, but there are also other research institutes like PSI, EWAG, and WSL. So they are focusing on the different aspects, and so EMPA is located in three, let's say, places in Switzerland. So there is one campus in Dubendorf where we are based. Then there is at St. Gallen, and there is in Thun. And let's say like EMPA research focuses mainly on the fields of energy, built environment, health, security, and yeah, these are the main areas of focus of EMPA. And yeah, talking about our lab in
Yeah.
particular, so I am from the Urban Energy Systems Lab, and our goal mainly lies on how we can design or have buildings operate toward or making them more energy efficient or less carbon emissive, and we are trying to do it on a different scale. So starting from the building scale and also going to the multi energy systems level. So where you have the grid, where you have the buildings, where you have the different centralized generation systems. So and also like quite interesting, we have this Nest demonstrator where we can really test technologies or solutions that we develop. So we can deploy there and we can test in real time. So it's quite interesting. And for me, like coming from the academic background, I liked this approach of EMPA that it's a very application oriented research, always in collaboration with industrial partners. And I think this is something that I really like to do, or like you can develop solutions and you can see where it fits in the in the real world application. So yeah, that's a bit about EMPA in our lab.
It's terrific. I had the opportunity, maybe in our post we'll link to this, but I had the opportunity to visit the EMPA lab. I thought lots of innovative things that they're not just the material science, but to your point about application, there are real offices and there are people who are living in these buildings. They're not just kind of off to the side. And little things like putting a data center in the basement, and the heat from the data center and those computers being used to heat the building, right? And all kinds of different innovative.
Yeah, exactly. I mean, it's kind of a simulation of what you would like to see.
Yeah.
So I think it's fits well that before it's applied in the real world, we test it thoroughly as much as possible in the demonstrators that we have.
Yeah.
So as you said, like yeah, we are trying to do this there.
Yeah. Well, terrific. So you picked buildings. I love that you said you have passion for it, right? We have a value at VIA around love in, love out. If you love what you do, it shows, and I think it clearly shows that you love buildings. We think about, often people talk about transportation as being carbon emitters, or tell us about buildings and their contribution.
Well, yeah, I mean, right, as you rightly said, like we, in most of the research that we are seeing, that we see that the buildings are like one of the sectors that emit the most, let's say, the greenhouse gas emissions, or consume the most energy. And just to put a few numbers, it's like 40% of the total energy consumption among all the sectors, and also like 33% of all the emissions that come from any sector.
Yeah.
So, and it's a lot. And here we are not just talking about the buildings during the operational phase, but also during the construction phase, all the embodied carbons that are in the materials or during the construction process. So here, for example, I mean, during the operational phase of the buildings, you can adopt different measures. For example, you can try to minimize the use of heating, ventilation, or cooling systems, or use them as much as required. Try to, dim the lights as much as possible, or, for example, not use optimize the use of the different appliances that all contribute to the energy usage in the building. But also, like, these are the measures that you take when it's in the operation phase. But the more on the construction side, these let's say these emissions, they already take place when the building are already there, so there is not much room to do anything about it when it's there. So I think in all the process where that comes before the construction, so the extraction of the raw materials, or the processing of the raw materials, or, for example, using the materials that goes into the building, I think if we kind of think about sustainable ways that we can do it, I think that goes a long way in reducing the burden that comes from the buildings as a contributor to the energy usage, or to the emissions that goes into the environment.
Yeah. So you raised a lot of good points there. I'm going to deep dive on one or two, which is, when we talk about transportation, we have options, right? Maybe we don't travel, right? Or maybe we can use public transportation. But buildings, we all need to live somewhere, right? And you're raising another point around, we actually don't have some choices. We are human beings and need to feel warm, right? We actually can't turn the heat all the way down on our buildings, and we actually can't have them too hot, right? And we can't. And so one of the I think your area of specialization you mentioned is around user behavior.
Sure.
Tell us a little bit about that area and that intersection, because I think mostly what we read about is like new materials, or, hey, everybody just turn your thermostat down.
Sure.
I'd love to hear more about what your specific area.
Sure. I mean here, like, maybe I was being a bit more, let's say, strict, and when I said, like, turning off the heating. But I think a lot of the decisions that the user make, for example, not like in the operation, but also like the purchase of appliances. You can purchase appliances that have a very good rating, like in terms of the energy efficiency, or you can choose to have lightings in the buildings that are very energy efficient. So these are little things that, like, more on the passive user behavior side, that can help to improve, let's say, the performance of the building. But also, like, in the past, like when you're talking about the intersection of the user behavior and the energy system, I think like, going back a bit to my PhD research, we did a lot of field studies in. So, for example, the first one was in Tuva, Russia, and so we are talking about a place where there are very extreme winters, so minus 35 to minus 40 degrees centigrade. And our goal was to understand what is the user perception of the environment that they're living in. So how can they feel comfortable? And it's the outdoor temperature, for sure, but it reflects on the inner building as well. And as we know, like the building, let's say the insulation and the buildings that they were living in were not so great, and it was reflected in the buildings inside. And we did few other field studies in office buildings in Switzerland, and there was to more understand, like, during the real operation of the office buildings, how are people, like, how is the indoor environment varying, and what the people are feeling. And overall, as a sum of all these research studies, we figured that the current building standards can be a bit too restrictive on the temperature set points that they're recommending. So this creates like some issues on two different levels. So the first is, like, we are having too much operational energy usage for conditioning the building, but at the same time, like, we are creating an environment where the temperature is very narrow, and it doesn't let the metabolic activity or the metabolic rate of the human body to vary, and this can be let's say, it's not good in the long term. So, and linked to that, what we were trying to do was that explore what is the solution to that. And we thought, like, why not try to create an indoor environment where we let the indoor temperature vary a bit more. So, for example, instead of having 21 degrees centigrade constantly for heating, why not let it vary from 18 to 21 degrees? And so we can kill two birds with the same stone. So it's like we can save energy, and also we can let the metabolic let's say excursion of the human body. But problem lies there is that it's very difficult to do it with conventional control techniques, and that's where machine learning comes in.
Okay.
And machine learning offers a lot of solution, and based on like our research, like we developed like this machine learning based controls, which we tested in co-simulation environment, but also in real in real climate chambers, and we really saw that we can reduce the energy use by about 30-40%.
Oh, really?
And also like we increase the time when we are exposing people to this dynamic indoor environment.
Yeah. Okay. So first, for those of us in the office now, anytime anybody says, "Oh, it's too hot or too cold," I'm going to say, "It's for your metabolic rate. It's for your own, it's for your own good." That's we're so. Arnab told me that it was the right thing to do.
Sorry, guys.
So actually, you also bring up a good point around that. First, I didn't know that fact. Always good. Second is around AI and machine learning. You mentioned this. I can see how machine learning does play a role here. Are you connecting sensors to people as well to be able to train algorithms? Or I'm curious more about what you're doing in that area, and especially as like Gen AI is kind of is that having an impact as you're thinking about algorithms and models for buildings?
Sure. As you said, like, I mean, I would just give you a couple of instances where I had real, interaction with how AI can create a difference. So, for example, as I said, like what we were trying to achieve before was difficult to achieve with conventional control techniques. But the big advantage of AI in a lot like certain family of algorithms is that they are not model based. So like they are not limited by the constraints of the variety of the buildings. So it's not like you have to develop one kind of algorithm for one building, and if the building changes a lot, then you have to look for we have to fine tune it a lot. But the advantage here lies the being model free. This kind of algorithms, they can learn in the environment. So it's like you just of course there are some fine tuning that are involved, but it's like learning in real time. So it's like has a closed feedback loop. So it's like it's gathering the environment, then if in the first few phases, if there is the human involved in the process, and it takes the human feedback into consideration, then after some time it can work more autonomously. So we have seen that it can actually solve the problem of dependency on the contextual, let's say the HVAC system side. But also on the other side, like currently, we are trying to disaggregate the loads from smart meters from a lot of residences in Switzerland. And one problem here is that most of the smart meters in Switzerland, as in other countries, they record data at very low frequency. So it's like mostly 15 minutes interval. And for any kind of load disaggregation activity, this is not a very good sampling resolution, let's say. And recently, a bit of time before, not so recently, we came across a lot of, let's say, AI algorithms, so GANs or CNNs, that can actually, they have been used actively for increasing the resolution of images. And we are trying to explore how we can deploy the same to increase the resolution of data in our case. And if we are successful, and then we can actually, without doing anything from the smart meter technology side, we can actually more use the same data and actually gather more information from there. And actually, this opens up a lot big potential. Like using this data, we can kind of segment the customers, identify which customers are using a lot more energy, and if they want our feedback, we can provide this feedback to them, and we can also, based on our expertise, we can suggest ways how they can reduce their energy usage. So I think AI has a big role to play in many different fields. I mean, I just mentioned a couple, but the potentials are enormous.
So many interesting things there. I think for our own group, we're learning lots. I'd say we've been thinking about non-intrusive load monitoring and AI algorithms and buildings for, and that the blocker of not having the data has always been, the biggest issue.
Yeah.
That idea of, no support, no wonder EPFL is number one, and emphasize that idea of using the AI to interpolate and be able to create more data and higher resolution makes a lot of sense. So it's incredible.
Yes, we are trying. I mean, it's not given that it will work, but worth to try, let's say.
Yeah, terrific. Well, this is your first trip to Boston.
Yes.
By the way, Milan, Switzerland, those are, beautiful places. From an energy perspective and building perspective, do you see, a lot of similarities or a lot of differences? How are you thinking about, when you, from that perspective, geographically?
Well, I mean, on a general level, I would say that there are a few differences that actually come from the cultural differences, building practices, or the general energy policies. So, I mean, in Switzerland, in recent times, I feel that there is a general feeling of energy awareness, and like people are conscious about how they are using energies in the buildings. They are trying to use more energy efficient appliances, and I think this is a direct reflection of the building standards. For example, the Minergie that is in Switzerland, and it recommends mostly wherever possible low energy consumption buildings, and and you see the reflection of that when people are using energy in the buildings, or when people are using the different in different sectors as well. I mean, another example that I would give you is that, like, in Switzerland, the public transportation framework is or landscape is quite nice, and I think there is a big difference in that aspect in the US. From my limited experience here in USA, I feel that in USA there is a lot more dependency on personal vehicles. So I think that contributes to a bit more on the emission side or energy usage side.
Yeah.
And again, I mean, also from the building perspective, I think the buildings here in the USA are larger in general, and there's a lot of usage of air conditioning, which is not so prevalent in Switzerland. So there are some fine differences that in the end, contribute to this to the energy consumptions. And I was just checking some figures in the IEA, so the International Energy Agency website, and I saw that over the last 20 years, the per capita energy usage in Switzerland has gone down by about 35% in the last 20 years. By 35, almost 35%. Wow. Yeah. Whereas in the US, it has only gone down by 6% in the last 20 years. So I think, I mean, USA is a big country, let's say, is a big country, and there are states, for example, California, which is setting standards for, very innovative green building practices. But then there are other, let's say, states which is a bit lagging behind. And I think Switzerland being a small country, there is not this problem of geographical differences. Yeah. So I think, like, in general, I feel that there is awareness everywhere about the moving towards a more greener future.
Yeah. I'm hopeful that's true, right? You raise good points, which are, the U.S. It has this huge geographic diversity. So yes. what will work in Texas may not work in North Dakota, right? Or extreme climates, right? And so, or Alaska, right?
Exactly.
Hawaii. So we're gonna see some differences, but the averages actually are interesting to hear. I also look at our own building with 10, these are pretty tall ceilings, right? 5 meter, 25 feet ceilings. Like, oh yeah, these are probably, and big glass. It's like, this is beautiful, but also maybe, energy efficiency. There's lots of things we could be doing, right? To your point. So
sure, absolutely, as you said.
Well, we appreciate you coming to visit us here in Boston. What brings you here to the U.S. in the first place? What brought you here?
Yeah, sure. So the main purpose, was there was a workshop that was being organized by the Northeastern University, and that workshop is kind of in association to an upcoming annex. So this annex is closely related to the Sweet Lantern project that we are currently that I'm focusing on currently right now, and we felt that is would be interesting for us to get involved in this annex and get some input from peers from other universities that are working in the same research areas. And overall, from this meeting, I felt like it was quite positive, and there is overall like a common, let's say, research interest towards designing buildings or operating buildings, taking into consideration the energy transition and also the possible future climate changes. So not just climate changes, but also extreme events that we have been already been exposed to a bit in the last decade. So what I'm talking about are like pandemics and how they kind of change the operation of the building. So all of a sudden you have like these residential buildings which are being used 24/7. Or, for example, geopolitical crises, for example, a war happening in another country, and how this affects how you're heating your building. So, so all these kind of issues, and at the heart of this research is also the fact that, sure, we want to improve the design of buildings, we want to consider the operation of the buildings, but not at the expense of the well-being or equitable access to energy of the users. So that is at the heart of this project. And of course, like when we are talking about extreme events, the topic, the keywords of sufficiency, resiliency, sustainability pops up. So these themes are kind of ingrained in the research topics as well here.
Yeah. So, you know, you tie us back to mission, right? We have a strong mission to be around cleaner, safer, more equitable communities. And it sounds like all of these things are tying together. Your work with SWEET, which is the Swiss Energy Transformation, big initiative, 8-year, plus initiative run by the VFA, the Swiss Federal Office of Energy,
exactly,
and sponsored. It's great to see that initiative kick off and underway, and delighted to be part of that as well. So, but I guess we're kind of running out of time here, so I'll say there's a whole nother session we could have about that topic.
Sure.
I look forward to doing that at another time. But vielen Dank, thank you very much for your time today, and I appreciate you coming out to visit us.
Thank you so much for having me here, and this interaction was great. And sure, I look forward to talk more about Sweet Lantern or other topics with you in the future. So
terrific. Thanks very much, Arnab.
Thank you.
All right. Great.